Okay, so Lorenzo, many thanks for organizing together with your team and having us here. It's really a pleasure coming and being part of the history, first event ever, JanusCon. So thank you. Okay, so this stand or okay. So yeah, um, hello everybody. My name is Dan Bogos. I'm part of CGRateS development team. And as I said, I'm very honored to be here today. Regarding our company, it's located within Germany, Bavaria. You all know about Oktoberfest, which is these days. By the way, it already started if you haven't booked your flights. So we got over 11 years by now of experience of architecting server-side solutions in VoIP environment. We got platform implementations covering both wholesale as well as retail, you know, old classical VoIP. And at some point, we needed a billing system. So we tried to shop around. It was nothing to satisfy our demands. And we decided to write one ourselves. That was back in 2010. We picked a language. By that time, it was quite exotic. We wrote the software in Go. When we started with Go, Go was a weekly release stage. They didn't have yet a stable version. And since we had investment for the project, we said, why not? It's their money. Let's try it. So we were very lucky. We did the right choice. So that makes us one of the oldest projects in Golang around. Regarding CGRateS, it's a mixture. You can call it a framework. We call it real-time enterprise billing suite because its enterprise is customizable, and it's a suite of services or daemons. It should be pluggable into existing infrastructures. So if you already have even a billing system and you just need to rate and do it fast, it should be able to cope with that. It should be also is designed to accommodate new components into networks, ISP, ITSP. For example, if you want to add a communication switch or an SMS service or nowadays a WebRTC service. And it should be also non-intrusive, so you don't have to proxy your traffic through our components. We just exchange information with that. It's all open source software. The full sources are available on GitHub, so you can fork it, you can do whatever you want with it. We have no add-ons in private repositories. People ask us about web portals or other services. We have nothing but what is already there. And we have consideration for community contribution. So we welcome you to join. It's a performance-oriented project. For that, we have built-in advanced caching system. A lot of what we do relies on that. It's transactional. It supports LRU, this least record used in the cache. It supports timing out the record. So when we cache information, we also can tell that it should auto expire in 1 hour or 1 day. From day one, we are asynchronous. If you know Golang, you know it's built towards this politics. So it's all done in within microthreads. This is why we can also scale a lot within asynchronous processing because we don't rely on system threads. It's a test-driven development project. Since we started, we were always taking care about testing. Today we have over 5,000 tests, there are chances that there are way more because we stopped counting like a couple of years ago. So also we declare our master as being stable, just because we have unit tests, we have integration tests, and we have also call simulation tests. So every time we push to production, we have to master, we have Travis, which runs all our test suite. So it's all automated. That's also the reason how we can survive with rather limited development resources. Just a bit of history of the code, just to be aware about our activities. On the left side, you can see we started pushing to GitHub around 2012, and since 2013, it's hard to find a month without commits, and as average, we have around 100 commits a month. So that makes us, especially OpenHub declares us as a highly active open source project. The architecture is a modular one. It's cloud ready, so if you want to run it in any kind of cloud environment you like, whether it's Kubernetes, whether it's Amazon, whether it's bare metal, we have all sorts of success stories on all these platforms. It's based on microservices with rich set of RPC APIs. Actually, this is how we communicate with the service. So it's all RPC based. Even our components, they talk to each other via RPC. If you want to enhance anything and you are forced not to obey the GPL license of the modules, you are able to simply replace one of our service with your own. So you have your own ownership because you can then communicate over RPC with us. It's a feature-rich project, so we have what people are calling online charging system. We have also offline charging system. We are multi-tenant from day one. We have real-time configuration reloads. Since we are heavily cache-based, we tend to restart the process as less as possible because we have running installations which are caching sometimes up to 10 GB of data. So this is why we prefer not to restart very often. It's the rating engine, the initial component of ours has support for derived charging. This is a possibility of rating each event or each CDR multiple times. For example, if you want to know the price for your customer, price for your distributor, price for your which you need to pay to your supplier in case of termination. We do that in real time, so you can have many simulated sessions as well. We have also a number rating, account bundles, session or event charging with balance reservation and refunds, this traditional prepaid, CDR logging with support for interim records, and rating queues. These are interesting because if you want to integrate into existing infrastructure, you might want to send us the CDR in real time, or your events which your platform produces in real time. We rate them, and few milliseconds we send them back to you. This is what we call rating queues. So we push the same CDR which you send us already rated. So it looks like it comes already from your communication switch, your platform already rated, which is kind of cool because you don't need to change much into your existing infrastructure. We have fraud detection with automatic mitigation, so you can relax over weekends. We shut down the accounts which we find not okay. We have support for the classic LCR. So if you want to know your suppliers, the cheaper supplier, the supplier with best quality, and so on, if you have routing demands, we have a subsystem doing that. This can be based on quality, or it can also interact with bundles if you receive a number of minutes or units from your supplier. We have call statistics with pattern monitoring, so you can do call statistics in real time. They are all stored in memory. We back them up on disk, but they are very quick and very light because they are objects in memory. We have an implementation of or implementations various servers within CGRateS. So we have a diameter server implementation. We call this agents. We have radius server implementation, and lately we have also added DNS server. So you can use CGRateS to build, for example, an enum routing server. These are fully standard agnostic because you can define their logic, their processing logic within some templates, JSON templates. We have also a resource allocation controller. So if you commit to giving some resources to your customers, you can use this controller to tell you whether they can still push channels or they can still push messages per second or whatever, depending on your commercial offering. API server, as I told you, with support for GOP. This is a binary protocol of Golang, binary encoding, JSON encoding, which is kind of standard nowadays, and we also support HTTP JSON server. We have also built-in high availability. And we also support dynamic partitioning. So this is our preferred way of scaling up. If you want to add multiple engines and components, you have a load balancer there. And we are quite excited always about new ideas and agile in developing new features. Now, the subject on my talk is build your own billing system, and I came to give you a quick receipt about how you can do it yourself without needing us. So before starting, you will install CGRateS. We provide an apt repository, so you don't have to, if you don't want to compile out of Go sources, which you should get away just fine with apt-get install CGRateS. Once you have this installed, you have to load the data. This data is the one which you will be using for defining your pricing and creating your accounts. So we call this data tariff plans, and this can be fed into CGRateS via two ways. One is via classic CDRs. CSV files. These are predefined formats, so you have to stick to the formats which we have. They are static formats, and you dump them on a disk and then call an API for the engine to process them, compile them, and store them as internal objects within our database. If CSV is too old or you don't like to work with them, you can use database stored data sources. So for the moment we support MySQL, Postgres, and Mongo. And we have full set of CRUD APIs for remote management. So if you are building your own web interface, you can use this to manage these APIs to manage the data, because then you don't have to, or we also don't recommend you reading directly the database at all. So you use our APIs to interact with the database. We have also a combination of two, so you can import initially the CSVs into database via calling some APIs, and then you can edit from that moment onwards via APIs. This data load or these data definitions serves mainly two purposes. So one would be for rating. So you would define your pricing for events, for destinations, for accounts, whatever. And this you do via what we call rating plans. These rating plans are attached to what we call rating subjects via rating profiles, and that's it. So you define your profiles and attach them to your subjects. The second part of your data definition would be accounting. Accounts are created in two ways again, via account actions. These are defined within your data sources via either CSVs again or within store database. Or you can also call directly APIs. So you can create accounts on the fly based on your maybe portal offering or based on external billing systems. So call APIs to get accounts created. Each account can have multiple balances, actually unlimited number of balances, and different balance types. So it can be voice, like minutes, it can be SMSs, it can be data. So we support multiple ways of charging. We also support actions which are run by scheduler. This is self-developed, so it's not cron. It's self-developed scheduler which reads your action plans and schedules running some actions. And these actions can be, for example, resetting your bundles at the beginning of each month. So you have all these automatic subscriptions covered there over these actions. And then you can have action triggers for fraud mitigation. And that's the accounting part. Once you have your data built, actually this is the first step. We also provide you templates, and so you can understand easier and start with something which is working already. Once you have this data built, you load it, as I told you, into the engine. The engine will compile it, and it will place it into our operational database, which we call DataDB. As DataDB, we support either Redis or Mongo. And this is obvious for speed reasons. Once you have the data defined, you are ready to start feeding in events. So these events can be either imported via classic CDRs like CSVs or so, or if it's a real-time application, you can feed events via APIs. So coming back to your WebRTC application, when the session starts, you will have to call some APIs. When the session ends, you would call some other APIs. And if you want to update in between, you can create a loop of calling APIs on CGRateS side. So CGRateS will work for you as your own internal modules in the end. And as I told you, you can scale quite a bit if you put a bit of effort on it. So let's imagine you are starting a session in your WebRTC app, and before allowing that session to start consuming resources, for example, before routing to a classical PSTN operator, you would like to make sure that your user has enough resources or is allowed to go out over that path. So you will call an API method on our side named authorize event on the object sessions. So calling that, you have quite some options. In the next APIs, I have simplified this, but I wanted to show you that you can also go more complex and deeper if you want to. So for example, here you could, if you want to specify that you want the attribute subsystem to also process this event, and this attribute subsystem is able to modify your request, even completely if you want. So it can alter your information or add new one for your event. It can also authorize resources, so it can check if you have channels available for that termination or channel available for that purpose, resources. It can check if you have enough balance, so get max usage, it's designed to check if you have enough balance and return you the number of minutes you are allowed to your session is allowed to go through. Process thresholds, it's accessing a special module subsystem for fraud detection. So thresholds will look if you have enough or if you have overloaded your system, or if it detects any suspicious activity. So process stats, it's also processing your event with the stats subsystem, for example, to limit the number of requests per second. Get suppliers, it will return you the routes for your event. So these routes are purely strings, so you can interpret these strings in the way you want in your application. So again, the CGRateS, it's pretty generic. It is not bounded to a specific industry. If you want your application to be old telephony related, VoIP, it can work just fine. Or if you want to be WebRTC or IoT, it can work again just fine. Suppliers max cost, it will limit the cost. It can also tell that I don't want to get a supplier which is more expensive than the price I'm selling to my customers, so I don't want to lose on this route, and the system can take decisions, clever decisions, protecting you from losing on the route. Ignoring errors is if you don't have pricing for this event for some suppliers, but you have for some others, we still consider that you did not populate correctly the data, and we will not return the suppliers back. If you choose ignoring errors, we will completely ignore the suppliers with errors, but still return you the others. And then there is the event, which is the real subject of your API call. And within this event, you can add data. So the data which you add, it's pretty flexible. We have few fields which we need, and what you add extra, it's up to you. In this case, we need an account, so we know from where to take money. We need the destination in case of telephony, so we know where you send the call to. We need an origin ID, so we know that this marks your session, this binds your session to this ID. It needs a request type. We support 4 different request types: prepaid, postpaid, pseudo prepaid, and rated. And then also you have to specify the setup time, so we can relate your event to pricing at specific time, because we support also prices with peak, off peaks, and other stuff which you might want to define. As a reply to your authorization, we return you, since all the others were disabled, all the other options, and only max usage was enabled. You can see that the answer in authorization, it populates only the max usage, and this is the value, watch out, it's in nanoseconds, because we support nanoseconds billing. This is not really designed to be user-friendly. I know it's hard to read that many zeros, us as a human, but it's towards machines, so they will have no problem in understanding that many zeros. If you see in some places, you can define also user-friendly usages, durations, like in this case 5 minutes. So this max usage helps you limiting your session to this one. For example, you can start a timer telling that my session will not go more than, in this case, I think it's like 3 days or something. Once you have passed authorization, you can call initiate session API telling us that, okay, from this moment we start billing. So we are serious, we have connected the call to or the session to remote, and we start billing. And then again, we need some fields. And this usage tells that I want to bill for just 5 minutes. So I want to reserve the duration of the next 5 minutes. And then we look if you have enough balances or bundles for the next 5 minutes. And we return you back again as nanoseconds the confirmation for the maximum usage which you can do in your session. In this case, the maximum usage is the same with what you have asked, but it can be also lower. So if you only have 3 minutes in your account, we will return you 3 minutes, and then it's your responsibility to cut your session after the 3 minutes. And this is the next API which you can use is update session. So you tell us after each 5 minutes, like a heartbeat, that you want 5 minutes more. And this you do until so long the session lasts. Or there is also the possibility that you ask us to start the internal heartbeat on our own. We are also able to do that. So in that case, you only start with initiate session, and you tell us when the session should terminate. And in between, we debit permanently out of your session, out of your balance. Here you can see again, for the update, we return you again the maximum usage which you can do, which is again similar to what you have asked. In the end, you call a session terminate, that your event is finished, and this tells us 12 minutes. This is a bit more than you have debited, because you realize that you clear out some stuff and you want to debit more. We detect that and we automatically debit 2 minutes more. So not only the 10 minutes which you have asked, but we add 2 minutes more to debit out of your account, and we also kill the session within our registers. Once everything is completed, you have to call another API to tell us, okay, this is my CDR. You can compare it with the session event and put a price on it, a cost on it. So this CDR, it's the same contains the same usage as your terminal session. So it will say 12 minutes. We look internally, we see that we have debited correctly, we find all the logs, and we save into CDR database. You can retrieve, as I told you, once you do process CDR, you can also receive it on your side already built. Or if you want to store it within our database, you will use afterwards get CDRs to retrieve the CDR. And this is how your CDR will look like based on here. It will contain a big blob of cost details. And there we write very detailed, each minute was taken from this balance, or each second or each nanosecond was taken from this balance or the other, and this part of this increment we have charged with this money and so on. So it's a detailed log of what we have built. So you can be fully compliant with your legal rules in your country. If you don't do session-based billing, you can also do process message, so per message, for example, SMSs or other messages which you want to bill. We support that as well. That does not create a session, or if it creates it, it's a virtual which is immediately also destroyed. So in this case, it has one more field which says category SMS in order to properly bill it from another balance. And this is what you get. Max usage is one, which allows you to do the billing. Some use cases which I could think of course, your market will tell you what you should bill and your demands, you know it yourself. But for example, if it's session-based billing, you can do the traditional telephony like, or bill your web conferences in different ways, your video calls in different ways. Support minutes in call centers, so premium support, IT support, whatever you want in your contact centers. Message-based billing, traditional SMS, MMS in IMS if you are aware about that, or various IoT scenarios. So I successfully made it in time. Huh?
Thanks, Dan. Let's give Dan a big round of applause, please.
Thank you very much.
I think we have time for one question for Dan. Do we have? Do we have one?
No one else?
No, I don't see anyone else.
Oh,
Okay.
maybe it's So you mentioned about Janice. You were looking at billing for Janice earlier, I believe. Is this? Would you consider like an integration with this? Because this looks pretty rich.
Yeah, this is definitely one of the options. So the idea is to basically work on a new way of, let's say, have an authentication pluggable architecture in Janus. So that I'm talking here about a very broad authentication or authorization in a very broad term. So it can be something that says accept this session or start billing this session or whatever. It can be a chain of plugins that can actually work together. And so I definitely see CGRateS as one of the models that could actually fit this new pluggable architecture. There will need to be some discussion about how to actually fit it into architecture, how we can actually better interact with CGRateS as well. But I'm definitely interested in playing with this. I already exchanged some ideas with Dan when I met him to discuss how this could actually work. He provided some examples, so I'm definitely looking forward to that.
I confirm.
So you're asking us to download a Debian package. Now, this is me being evil. I'm
not asking.
I went to your site, which is not trusted. It's HTTP. There's no HTTPS. And I read about downloading a Debian package over HTTP, not HTTPS, and there was no reference to the key you signed the package with. So how do I trust that I'm getting the right stuff from you?
Yes. So it's a bit of story because we had a breakdown of our website. So even our website is stored somewhere in internet. As I told you, we are very focused over software and not really on websites. And our app is secured and signed. So if you go... Okay, so first thing we do when I go back, we'll publish our signature. Thank you.
Thank you, Dan. Thanks a lot.
Thank you very much.